when we're going to go and look at adding and subtracting, your notes from yesterday should already be glued here. Yours should say the right thing, mine's upside down. But if we take a look, add and subtract with scientific notation. When we add and subtract, let's just look at add. There's usually a little bit more work. The first thing we have to do, I wrote the wrong thing first, but we have to make the exponents on the powers of 10 the same. So the exponents have to be the same. And then we just add the constants. And then lastly, just make sure it is in scientific notation. So if we look at the example they give us, 2.5 times 10 to the third power plus 3 7/10 times 10 to the fifth power. Well, the exponents aren't the same, so you have to make them the same. Usually the best way to go is make them both the same as the greater exponent. So you can even make a note of that. So make exponents same as greatest exponent, because then you'll just get smaller decimals. So if we look at this one, we have an exponent 5, exponent 3, so we want to make the 5, both of them. So this one can stay the same. This one, remember to make, remember it's opposite of the number line. So if we want to make this greater, we have to move to the left. Usually left would be negative, but in this case left is positive. So to make it greater, move to the left. So we get 0.025 is what they have here. Now that they're the same, we can just add these numbers. So they add 25 thousandths plus 3 7/10, and they write that here, and they get this. And then you just keep whatever the exponent was before, times 10 to the fifth, whatever it was when you made them the same. Same thing with subtraction. So you make the exponents on the powers of 10 the same, and then you subtract the constants, and then just make sure it is in scientific notation. So same thing here, 5.6 times 10 to the 8th minus 4 2/10 times 10 to the 7th. Well, they're different exponents. So notice how they make it the smaller exponent, they make both of it 7. This is why I don't like to make them the smaller exponent, because when they do this, you'll see to make this smaller, they have to move the decimal to the right. So they end up getting a greater number. So they get this minus this, which is fine, but just at the very end, since 51.8 times 10 to the 7th isn't correct scientific notation, they have to go back and make it in scientific notation again. Whereas if you were to do it with making the larger, making both of them a larger number, you wouldn't have to fix this at the end. So let's go ahead and try that as our example. Let's do 5.6 times 10 to the 8th, and let's just write it on our actual notebook. So they have 5.6 times 10 to the 8th minus, and then 4.2 times 10 to the 7th, just so you can see the difference. So if we make both of them 8, well, that means we'd have to move this one over once. So then we would get 5.6 times 10 to the 8th. We moved that, so it turned into 42 hundredths times 10 to the 8th. And then when we subtract this, right away we get this answer, 5 18 hundredths. So we just subtract, and I can write it out, 5.6 minus 42 hundredths, and then it's still times 10 to the 8th. So right away we get 5 18 hundredths times 10 to the 8th. So really you could do it either way, but if you make both of them the smaller exponent like they did, you have to do some extra work at the end to make it in correct scientific notation. All right, I want you to try a couple examples using your notes, see how it goes, and then we will look at them together. So I want you to do 2.5 there shouldn't be parentheses there, times 10 to the 6th plus 4 times 10 to the 6th. And then also try 6 23 hundredths, 6.23 times 10 to the 5th minus 2 1/10 times 10 to the 4th. So go ahead and try both of those using your notes. Remember, make the exponents the same, add or subtract the constants, and then just bring down your exponent to right-hand scientific notation. Okay, so let's take a look at the answers for these. So the exponents are already the same, so we don't really have to do much work for this. We just have to add the constants. If you want to write it out, so you know you have to do 2.5 plus 4, and then it's just going to be times 10 to the 6, you can. If you just want to add right away, that's fine too. So 2 5/10 plus 4, we get 6 5/10 times 10 to the 6. And it's in scientific notation, it's between 1 and 10, so we're good. That's our answer. And then if we look at this one, they're not the same exponent. We have 5 and 4, so we have to make them the same exponent. Well, the greater one is 5, so let's turn this into a 5. Remember, to make our exponent go up, we have to move our decimal to the left. So we just want it to go up 1 from 4 to 5, so we'll move our decimal over once to the left. So now this turns into 6 23/100 times 10 to the 5th minus 21/100 times 10 to the 5th. Now we can just subtract 6 23/100 minus 21/100, and it's still going to be 10 to the 5th. So now when we do this subtraction, we end up getting 6 2/100 times 10 to the 5th. Just keep your exponent the same. All right, we'll look at these more tomorrow.